So today we're going to be starting with arithmetic and logical operations in R. Just as we know that R is used for many things: data analysis, statistical analysis, machine learning, data science, data engineering, and the likes. So for today, we're going to be seeing how you can do basic arithmetic and logical operations in R. So we're going to be taking R: addition, subtraction, multiplication, division, exponents, integer division, and remainder division under that. So this is the R studio software. So here, this is an R script, while this is the R console. Whatever I run here will be displayed here. And I can as well just run it here directly and have my answer. But it's better to have it done in the R script. You know, R scripts, you can use it, you can reproduce it. I mean, once you have it and you save it, you can hand it over to someone, but then the person can also run the codes in it. But on R console here, once you have it, you can only print out the final thing. So it's better to have it on your R script than you run it and have it on your R console, so you can use it again. So for addition, where is it? I hope Miss Naima is with us.
Yes,
Okay. So yesterday we talked about this hash symbol, and said it's used for commenting. So that's one thing I'm using it for. So anytime you see this hash symbol, anything that comes after it, I will not recognize it. So arithmetic, addition. So for addition, okay, let's say we want to do 4 plus 5 as we have on our screen here. 4 plus 5. So what I'll do is I'll highlight it, then press Ctrl Enter. Can we see it's displayed here in our R console? So 4 plus 5 equals 9. Then another one that we can have is, okay, let's have our variables. Variable A equals to 9. Then variable B equals to, okay, variable A equals to 8. Variable B equals to 9. Then a variable Z is going to be equals to the addition, the sum of variable A and variable B. So let's run that. Remember, we highlight everything, then press Ctrl Enter. So if I want to print out Z, just type Z. Can you see? So Z is the sum of variables A and B, where variable A equals to 8 and variable B equals to 9. So, and the sum of both equals to 17. So that's that for Z. So I have Y equals to X equals to Z. So U equals to A plus B times Y divided by X. Plus Z raised to the power of 5 minus 10,000. So having assigned my Y variable to be equal to X to be equal to Z, then U equals to A plus B into brackets multiplied by Y divided by X plus Z raised to the power of 5 minus 10,000. So let me bring out my, okay, let's So from here, let's run this code first to see what z and y is. From here we say y equals to x equals to z. Less than, then minus is this. This one I've highlighted there is an assignment operator in R. It also denotes equals to. So it's the same thing as is equals to. It's an assignment operator. So it says y equals to x equals to z. So then if I should print out my x2, you see it as 17. So from here it says, okay, u equals to a plus b times y divided by x plus z raised by 5 minus 10,000. So let's print out u2. So let's run this code and print it out. Oh, sorry. Remember, R is case sensitive. It's because the Z I have up here is in lowercase. So bringing out another one here in uppercase, it's a different entity entirely. So that's why it's brought out this error here, object Z not found. So I've changed it back to the lowercase, which I have up there. So we can now have the answer to be 1,409,874. So this is it for addition. So now let's move on to another one. So for this one now, we've been able to do, okay, addition, multiplication, division, then exponential, then subtraction too. So then we can also have these. When I say 78 divided by 5, then run it. When I run this code here, it gives me 15.6, right? So 15.6 here is a decimal number. So in case I'm only interested in having the integer part of this operation here, I'm going to use 78 divided by 5. 78% divide %5. So that's going to give us only the integer part of the answer, and that's 15. 15 is integer part. Remember, integer do not have decimal points. So in case you're interested in having just the integer number without the decimal points, use this style. Then also for modulo, remember modulo is used for getting the remainder after a division is done. So let's say 76 divide modulo 3. Oh, that's 1. That means when I divide 76 divided by 3, what remains? So that's that. Then if I should also do 20 modulo 5, I expect this to be 0. So this is 0. This is it. This is 0. And that's because 5 is actually part of 20, is a factor of 20. So that's now moving on. So yes, Miss Naima, we have the YouTube channel on the link to the YouTube channel on the chat box, in the chat box. So now we have comparison operators. We have double equal to, we have exclamation mark and equal to, we have greater than, less than or equal to, greater than or equal to. Then we have logical operators. So for this, let's demonstrate it here. So remember, let me comment it this way. Comparison operators. Comparison operators. So as the name implies already, the comparison operators are used for comparing two or more variables or values. So let's have variable A. No. Variable M equals to 23. Variable n equals to 12. Then variable L equals to 10. So let's do some comparison here. So if I want to compare if actually variable m, no, then let's have variable f equals to m plus n minus L. Minus L. Okay, no, minus 3L. Let's have it this way. Minus 3 times L. So this is variable f. Let's have this in brackets. So this is variable f. So let's run this code first before moving on. So from here, it says variable f equals to 5. And that's because we have 23 plus 12, that's 35, minus 3 times 10, that's 30. So 35 minus 30 will give us 5. So now let's do some comparison. So is m less than n? So to confirm this, it's going to be m less than n. False. False means it's not. From here, it says m is not less than n. From what we have here, this is a Boolean value saying false, that no, m is not less than n. So then, is n less than n? From here, it says true. So this confirms that the value of n is actually less than the value of n. So we can as well confirm this, that is m equals to m exponential 1. True. So this means that m exponential 1 equals to the value of m, which is 23, is also equals to the value of m raised by 1, which is as well 23. So this confirms that for us. So then if you want to confirm that is m not equals to is this, we have the exclamation mark, then the equals to sign, that is m not equal to m exponential 2. This should give us true. Yes, this confirms it, that's true, that m is actually not the same thing as m exponential 2. And m exponential 2 in itself is m times m. And m times m will be 23 times 23, which is obviously not the same thing as m, which is just 23. So then we can also have less than or equals to. So if I say m is less than or equals to, that is m less than or equals to L. So what does this give us? False, that m is actually not less than or equal to, which means m is actually greater than n. That's the implication here. Then let's confirm if the value of f equals to the value of m divided by 2. It says false, that no. How about we check if the value of f is less than or equals to m divided by 2? So yes, the value of f is 5. Remember, we checked earlier, which is here. So it says the value of f, which is 5. 5 is less than or equal to 23 divided by 2, which is 11.5. Yes, 5 is less than 11.5. That's true. So we have it true here. So that's how for our arithmetic, our comparison operators. We've been able to compare the value of one variable with another one. See if some are less than, greater than, not equals to, or equals to. So now so we have the logical operators. Then we have, okay, this means and, this means or, and this means not equals. This means not. So that's that for that. So then moving on, data types. In R, we have 5 major data types. We have numeric, integer, complex, character, and logical. So we're going to be taking them one after the other. So for this workshop, we're going to just take numeric, integer, character, and logical, these 2 types. So for the numeric is numeric and integer. Let me take both together. Numeric values, the numeric data type is such that its values are going to be decimal number. It can have decimal number as its value. But for integer does not take decimal numbers. So we have numeric, integer, character, then logical. So to confirm the type of the class, the variable type, the data type of a variable, we use the class function. So you use class function to get the data type of a variable. So let's move on. Let's have some answer on that. So not to forget our comments to make our code interesting and readable. So make it okay, data types. So for data types, okay, numeric. So for numeric, A equals to 45, B equals to 4.3. So if I should check for the data type of variable A and the data type of variable B, let's see what we have. So for variable A, class of variable A is, and so I like them. So it says variable A is numeric and variable B is numeric too. So it has, this one has decimal points, yes, then this one too, even though it doesn't have decimal points, it's numeric because it doesn't have this symbol here. So in R, to make it to an integer in R, we have this L symbol here. So then let's have, okay, variable C equals to 3L, then variable D equals to 45L. So then let's see variable E. $56.9L, and let's see what comes out. So let's confirm the class, the data type of each one of them. Yes, so it says variable, yes, it says variable C is an integer, variable D is an integer, and variable E is a numeric. Why? Because it has a decimal point. Remember, this one also has a decimal, so that will make it a numeric instead of an integer. So not an integer with return error because it contains decimal. Yes, this one to actually return an error. Can you see warning message? Integer literal 56.9L contains decimal using numeric value. So now we have character. The character data type contains string values. That is anything having alphabets. So for the name, we have the name variable equals to Joy, the sex variable equals to male. Then we want to confirm the data type of each of these two variables. So it says character. So how about when we have a variable that has something like this? Okay, age equals to 34. So data type of age we want. It's character, and that's because it's put into it has these double quotes. So anything that has these double quotes, any value in it, R since it has character and not integer, even if it is just not numeric, even if it's numbers like it has in it. So for character, we can have anything. It could be alphabet, it could be numeric, it could be alphabet, it could be numbers, then it could be alphanumeric. So far they are put it to these double quotes here. It sees it as character data type. So then for logical, so for the logical data type, you have, okay, just as we did earlier when we were doing comparison. So for each of these comparison, the data type being returned here, that's what we see as logical. That's true or false. X equals to 2. Then y equals to 5 less than 1. So if I should check for the class of each of these two variables, variables x and variable y. So they are both logical. The variable class of x is logical, then class of y2 is logical. So next one, okay. So data structures. So in R, a collection of data types which can be similar or different from each other. That's what we refer as data structures. And data structure can be one of these 6 major types. You have vectors, lists, matrices, arrays, data frames, and factors. So let's look at them one after the other. So for vectors, vectors contain items or values of the same data type. So in a vector, you can have items of more than one data type. I mean, if it's just going to be characters, you have characters like these colors variable. Then if it's going to be integers, you have integers all through. And it's going to be numeric, you have numeric all through as this prime number. And so let's run our quiz to confirm this. So I'm going to start with the structures. So colors. Remember, I submit the operator. So C is used to concatenate more than one. When you have a variable that has more than one value, it could be either numeric, it could be character, any which one. So if you have more than one value in a variable, you use this C concatenate to concatenate them together. So the first one I have blue, I have color green, I have color yellow. Remember to always include the quotation and the quotes. Then we have black, then whites. So let's print out colors. So we have blue, green, yellow, black, then whites. So then another variable, that's prime number. So for prime number here, you have values 1, 3, 5, 7, 11, 13, 17, 19. Okay, let's stop at 19. Let's stop at 19. So let's print out prime number. So this is our prime number. So colors variable and prime number variable are vectors because they have just one, they contain only one data type of variable or values. Then logical too. For logical, yeah, true, and well, false. Let me bring that out. Logical. So this is that. So logical, prime number, and colors variables are examples of vector data structures. So on to the next, you have so we can check for the length of vector using the length function. Then you can as well sort a vector with the sort function, as you can see here. So let's check for the length of our variables. For length, you mean how many values are included in the variables. So for variables vector, so it's a length of colors. That will give us so that tells us that we have 5 different colors in this color variable. Here we have blue, green, yellow, black, white. So if you count them, that's right. But then there are times that we have more than enough that you can't count easily. So just use the length function as you just tweaked there to check for the number of values included in the variable. So for prime number 2, you can check, okay, length of prime numbers and length of prime number. So that's 8. That means I have 8 prime numbers included in the prime number variable here. So then we want to sort. Let's sort for, let's say we have a variable where, okay, let's create a variable like this one. Okay. Let's copy it and paste here. So looking at these variable numbers here, the numbers are not sorted, they are just mixed up. I have 14 and I have 3, I have 5. But then I want to have them in a descending manner or ascending manner. So I use sort. So sort here, give me the presentation of these values in an ascending manner. So I have 0, 1, 3, 5, 6, 9, 10, 13, 14. So this tells us that 14 is the highest, while 0 is the lowest number included in the numbers variable. So we can access an item in a vector by its index number. By index number, we mean, okay, for banana here, banana is number 1, orange is number 2, watermelon is number 3, while purple is number. Oh yeah, so it says, okay, the second item included in the fruits variable is orange. So you can as well use negative numbers for index. Using negative numbers for index to access all items except the one specified. So here now, if I say fruits with the index of -1, with the index of -1, one is banana, remember? So one is banana. So it will just remove one and give me the other ones, which is orange, watermelon, then purple. So then I have to access multiple elements, use the concatenate, then use the square brackets as you before, then this. So just run this here. So we have orange and watermelon because they have 2 and 3. Those are the ones at the second and third index number. Then we can as well use this. So we can as well use this will say 2 to 3. So orange and watermelon. So now we're going moving on to lists. So lists contain many different data types. So unlike vectors, which just allow for one data type, list allows for more than one. And yeah, allows for more than one. We can have integer, then we can have numeric, character, and as well logical in just one variable. So let's copy this and paste it. Let's run this way. So my list has Kano, Gombe, Bauchi, True, 8, then 20. So from here, I want to access the third item in this list, which is Bauchi. So 1, 2, 3. Bauchi is number 3. So I just use this to access it. Then if I'm also interested in having the first item in my list variable as well, index it using 1. So that's Kanu. So that tells us Kanu is the first one there. So then we can change the value of an item in the list. So in case you want to change the value of an item in the list, use the index number of that item to change it. So that tells us that the item at number 4, the 4th item in my list variable, will be changed to girl now. The 4th item used to be 1, 2, 3, 4. That's true. So if you run this, print out my list variable now. You will see that we have Kano, Gombe, Bauchi, girl. Instead of Kano, Gombe, Bauchi, true, that we used to have here, it's now changed to girl. So that's how to change. Then you can as well remove items from a list by using negative indexing, just as this. So another list is the name of the variable that has all of my list items except for the first item, which is Kano. So unlike my list that has Kano as its first item, now we have it as Gombe. Gombe is the first because Kano is removed. So we have Gombe, Bauchi, girl, 8, 10, 20. Remember, my list's 4th item has been changed to girl earlier. So you can add an item to the end of a list with the append function. So in case you want to add an item to the end of a list, use the append function. So my list variable that I have here, it says I should add horse to the last of it. So let's run this. So the 7th item now will be horse. It used to be 6 before. So I have Kano, Gombe, Bauchi, girl, 8, 20, then horse. Also has been included. So now moving on to matrices. Matrix is a 2-dimensional data made up of columns and rows. And it is created with the matrix function. Remember earlier we said vector is created using the C function. List is created using list function. Then matrix is created using the matrix function. So let's create a 2x2 matrix of numbers. So this specifies it here that the number of rows will be 2 and the number of columns will be 2. So then the items in the matrix are, the elements of the matrix are 1, 2, 3, 4. Let's split it out. So 1, 2, 3, 4. So this is then a matrix of strings can also be created. Let's create a string matrix as well. So these has colors blue, white, red, green. Let's put it down. So blue, red, white, and green. Yes. So then we can as well access items in the matrix using our square brackets. This variable, this matrix variable here. The matrix variable here contains 2, 3, 5, 7, 11, up to 23 values. So these are prime numbers. So let's run it next. Then let's print it out. Let's print the whole matrix out. So it has 2, 3, 5, 7, 11, 13, 17, 19, 23. Okay. So now I want to print out an item there. So prime 2, 1. And that's 3. What this says is that the second, this is x, y, 2 represent x, y represents, or say 2 represents row, 1 represents column. So this says the item at the second row of the first column, and that's what the second row is here, first column, and that's 3. So when I'm interested in getting this 13, that's third row and the second column, and that would just be prime 3.2, and that should give me the item 13, just as I have here. So in case you're only interested in accessing only columns, you can do it this way. So to access only column 3, all of column 3, that's 17, 19, 23. So just use you do not put anything here for the row. So you have 17, 19, then 23. Then in case you're as well interested in just accessing only the row, say only row 2 as we have here. So you just only this way, then you have 3, 11, 19. That's row 2, 3, 11, 19. That's that. Then if you want to access more than one row, let's say you want to access 3 rows here. So you use the C function to concatenate the number of the specific rows together. Then you can run code here. So yes. So then we can add rows and columns to a matrix with the R bind and C bind function respectively. So to add rows, let's look at this new matrix variable. We've had the prime variable, the prime matrix area. So we want to add 29, 31, then 37 to the row of the already defined prime matrix. So 29, 31, 37 have been added successfully to the row of the prime variable. So then in case you want to add the columns, you use C bind, that's column bind, R row bind. Just as simple as that. So if you see new matrix now, so another column has been added, that's 29, 31, 37 to the prime variable. So you can check for the number of rows and columns with the dim function. That's the dimension. So we want to know the dimension of your matrix. Use the dim function. So that's 2, 2. 2 is for row. The first one is row. The second one is column. So this says 2 rows, 2 columns. So A matrix that we had earlier, see it, you can see it here. So this is A matrix, 2 rows and 2 columns. So that's for checking the number of rows and columns of a matrix. So the next data structure we'll be looking at is arrays. So like matrices, arrays have more than 2 dimensions. The array function is used to create an array. So remember vector C function, matrix function, list function, then array to array function. So let's create an array. So a vector, this variable name, a vector, has 1 to 30. Its numbers are 1 to 30. Let's print it out and see. So 1 to 30 as it's indicated here. So then an array of variable name, an array, we have, okay, let's print out an array to see how it is. It has an array. That's 5. Hope we can see it very quickly. This. So 5 rows, 2 columns in 3 places. 5 rows there. Look at the rows 1, 2, 3, 4, 5. Then the rows and the columns are 1, 2, 1, 2, then in 3 places. So the first is this, the second, then the third. And yes, okay, this is our array. So array items can also be accessed by indexing the square brackets, just as we've been doing. So you want to I'm interested in having the value of the item at the 5th row of the second column of the second table here. This is this one. So this is 5th to the second column. So this should print out 20. Yes, we have a value as 20. So in case you are interested in having this 18 value, this 18 here. So that's 3 column 2, the second table here. So I say an array, I square brackets, don't forget 3 column 2, column 2. So that's 18. So for the dimension of an array, use the dim function as well. So the dimension of this array, as we've known earlier, run this our code, that's 5 to 3. So then data frames, that's the next data structure we'll be looking at. There are this data displayed in a tabular form. It consists of columns of different data types, but each column contains values of the same data types. It's created with the data.frame function. You see, in data frame, you have different columns, but just that each column must have its values from the same data type. So here we have the name column, the age column, then the married column. So for here now we have Joy, John, Rebecca, 43, 21, 45, true, false, false. So we can have under this age string, everything here will be numeric, then everything here will be character, everything here logical. You can't mix them up. It's not allowed. Let's say we try and mix it up and then see it will return an error. Let's say I mistakenly put something like B. Okay, as a thing, return an error, but usually as this column is here, we're interested in doing some manipulations or transformations. Say you're interested in having some of these things here now. Since they do not have the same data type, you're going to be getting error. So even though it's not flagging out error here, when you move on with your data analysis, you're going to be getting error. So summary of workers. So can you see here? Okay, let's say this is workers. Then going back to the previous one, heading down to workers one. We define this then. The summary. The summary function is actually used to summarize a data frame. You summarize a data frame using the summary function. So it depends on the data type of the columns in the data frame. That's what will give you, okay, workers one. So you see, unlike the summary given here for workers, it has two different data types in the age column here. It just works it out here as length equals 3, class equals character, mode equals character. So it has sent all these other ones to character too in this thing here. But for the ones that has just one data type of values in each of the columns, you can see that for the age here, it's brought out the exact summary. It says the minimum is 21, the first quantile is 32, the median, the mean, the third, and the max is 45. Can you see? It's brought it out. So, but because we've altered this this thing here earlier, we've added value of another variable into this column, so we bring it out here as, even if it's not flagging it out as error, we sure will not get our desired value at the end of the day. So items in a variable can be assigned with square brackets, double brackets, or dollar signs. So in case you want to get access, you want to access some items in the variable. So this says, okay, workers 2. That's for the second column. This is workers. Okay. Let's say workers 1, 2. We've changed it here. So that's this workers 1. So the second column here, which is 43, 21, and 45. So I have it here. You can use the double brackets too. It's that one to get the other one here. So it brings it out as true, false, false. This one will bring it out, say like just the vector here. So then you can use the $sign too. The workers, then the $sign name. And you see this one brings it out too by the vector. We have Joy, John, then Rebecca. So this is a data frame. This one, this is the data frame. So how about this? Oh. Use that as logical. But this thing here is logical. So my dear, we have it as logical because we have true, false, false here. And this one so should give us these as character. Saying the item is character. So those dots. So you can add new rows and columns to the data using the rbind and cbind functions respectively. So we have the rbind, then the new workers data. Yeah. So in case you're interested in adding another column or row to your data, let's run this first. So this is the new workers data here. You can see it has another row, which is Johnson. So we want to add a new set of values to it. So for that, cbind. So you're adding a new column and it's name children with values 518. With values 518. So that's for the workers data type, workers variable we add earlier. So we can as well remove items using negative indexing. So this one here says we should remove the item at the third row of the second column from new workers data. This is our new workers variable here. So the third column, the third row is this, and the second value, and the second column is this. So it will just return, so you remove those ones and return the other ones. So the third row is removed, then the second column too is removed. So we now have
just the first and second rows and the first, third, and fourth columns. So you can combine two data frames using the cbind function. So this is the end result of having to combine new workers data and new workers data together here. So combined by columns, that one earlier combined by rows. So rbind we combine by columns. So this one here has combined by rows, just appended it, added more values to the same row. Unlike the other one did it with column size, added another column. But this one, no, they're using rbind to add it as another row. So this is where we're going to be stopping for today. So ensure to check out our YouTube channel for the recordings for today and some other workshops we've had in the past, like data analytics with Python and data analytics with Power BI. And don't forget to join us tomorrow, same time, for the next session. Thank you very much for joining.